Today we are going to talk about classifying rational numbers. We have 4 different sets or subsets of rational numbers, and the first one is natural numbers. And natural numbers are going to be your counting numbers, 1, 2, 3, 4, and so on. So if I were told you to count to 20, you would start off with the number 1 and go up from there. The next one that we have is whole numbers. Your whole numbers are going to be your counting numbers, but include 0. So when we count, we do not start at 0, we start at 1. So whole numbers are your positive numbers, counting numbers, and 0. After whole numbers, we have integers. Now, your integers are going to be 0, and then they are going to be your whole numbers and your opposite. When we say opposite, remember we mean your opposite of 5 would be -5. So this is the first set where negative numbers are included. So we would have 1, -1 would be its opposite, 2, -2 would be its opposite, 3, and -3 would be its opposite, and so on and so forth. There's supposed to be little dots. And then we have our last subset, which would be our rational numbers. And rational numbers are all numbers that can be written as fractions. So remember, we have already learned in the past that we can convert percents and decimals to fractions. So as long as the number can be written as a fraction, it is a rational number. Then we have just a little note that we can only move up the ladder. So meaning a natural is a whole number, which is an integer, which is a rational, but rational is not always a whole number. So we can only move up the ladder. And so something I like to do is we start at natural. So I like to write natural, then we move to whole, integer, and rational. And I draw an arrow down it because if I'm following the arrow, then I am true when classifying. So if I'm natural and I'm moving to a integer, I am following that arrow, therefore I am true. And that will make more sense whenever we look at this. So we can also write it as sideways, natural, whole, integer, rational, and follow the arrow from N to N to R. So it's asking if all natural numbers are whole numbers. Does that follow the arrow? Natural moving to whole, and it follows the arrow. That checks out. Therefore, it is true. Then it's asking if all whole numbers are natural numbers. So if I'm starting at whole right here, and I'm moving to natural, that's going the opposite direction of the arrow. Therefore, it is false. And then the next one is, are all rational numbers are integers. So it's asking me to start out here at R, and it's asking me to move to I. That is not true. Therefore, it is false. And then here is a Venn diagram for reference. Moving on, it says to classify each number by circling all sets of numbers to which it belongs. So if we're looking here, we have, if we draw our arrow, and we're looking at natural, whole, integer, rational, we identify what is 23. So we always want to start with looking at natural. If I am counting to 23 or 30, I'm including 23 on there. So therefore it's a natural number because it's a counting number. So it wants us to circle it. If I'm following my arrow, if that means that the more I go down, it is also true. So a natural number is also whole, it is also an integer, and it is also rational. Looking at negative 18, we have a negative in there. Therefore, we know that if I were to count to 20, I would never say negative 18, so therefore it's not a counting number. If I am a whole number, I am a counting number and 0. Therefore, I would never say negative 18 counting to 20. Integer are whole numbers and their opposites. So if I'm looking at negative 18, the opposite of negative 18 would be 18. That is a whole number and its opposite. Therefore, it is an integer. If it's an integer following my arrow, it is also a rational. Number 6. So at this point, if you want to look over to the side of your notes and write down any questions or key points, push pause and do that. I'm looking at 16 divided by 4. 16 divided by 4 is a fraction. So just by looking at the number, 16 divided by 4 is classified as which of these categories? And if you said rational, you are correct. But now I can't go up automatically. Therefore, I need to determine and start back at natural. If I simplify 16 over 4, that means 16 divided by 4. And we learned that in the past. And 16 divided by 4 is 4. Therefore, is 4 a counting number? Yes. When I count to 5, I do say the number 4. It is natural. Following the arrow, that means it is all of them. Going to number 7. Number 7 is a negative number. I want you to push pause and try to do this one on your own. Okay, so some notes real quick. It is a negative number, so therefore it's automatically not whole and it's automatically not natural. If I am looking, I also notice that there's a decimal. Integers are negative, but they're a whole number and it's opposite. Therefore, there's no decimals in an integer, so that does not work either. If I look at 36, that is 36 hundredths. When I convert decimals to fractions, I write it like I read it. 36 hundredths can be written as a fraction, therefore it is rational. I would like you to try to simplify 5 squared, working on our exponents, and then classifying. Push pause to solve and play when you are ready to move on. Okay, so an exponent means that it is 2 of whatever it's on top of. It is on top of a 5, so that means I have 2 5s, and the operation is always multiplication, giving you 25. 25 we know is a whole number, it's a natural number, it's an integer, and it's a rational number. Last one, 17%. If we go from decimal to percents, Dr. Pepper, if we move from a percent to a decimal, we move our decimal to the left, and there are 2 numbers, therefore we would move it 2 times. So a 17% decimal is here, move it 2 times, converts to 0.17. So we know that there's no decimals here, there's no decimals here, and there's no decimals here. Can it be written as a fraction? Remember, we write it like we read it. This is 17 hundredths, which is 17 over 100. Also, a percent is out of 100. So 17 out of 100 is how we would write that. So it is a rational number. Here is a problem that just involves solving. I just want to see how we use rational numbers in real life problems. So the time in seconds, so that means that t equals seconds. It takes for an object to fall d feet, that means d equals feet, is represented by the equation t equals the square root of d over 4. How many seconds would it take for a volleyball team, or for a volleyball thrown about 36 feet up in the air to fall from the highest point in the sand? So that means that we know that d equals 36. So it's asking the time, which is seconds. That means we're looking for t. So to plug in, we have t equals the square root of d, which is 36, divided by 4. The square root of 36 means what times what equals 36. And the answer to that is 6 times 6. So that means that t equals the square root of 36, which is 6, divided by 4. We could simplify that dividing by 2 on the top and bottom, and t would equal 3 over 2. That doesn't really make sense for time, so let's convert that to a decimal. 3 is on top, so 3. The fraction bar means divided by 2. 2 divided into 3 goes in one time, minus 2 with 1 left over. We have to add a decimal 0 and bring your decimal up and bring your 0 down. 2 divides into 10 5 times, minus 10, which is no remainder. Therefore, t is equivalent to 1.5 or 1.5 seconds, boxing my answer. If you have any questions, please make sure to write it down on your notes where it has your questions and key points.